Good morning. Morning, thank you. How's everybody doing? Been a good build? Yeah? Excellent. Oh.
Thank you very much. Bye.
So what's new in C# 6? What's new in Visual Basic 14? We're here to talk to you about that this morning. My name is Dustin Campbell. I work on the Managed Languages team, focusing on IDE experiences, IntelliSense, that sort of thing. And my compadre, my cohort.
Mads Torgersen. I'm the C# language lead. So I work on C#, the language, but I love VB.
That's right. That's right. So actually, we're going to focus pretty heavily on C# today. Our demos are primarily going to be in C# code. But I do want to mention that the things that we show today are pretty much all in Visual Basic, and we'll make note of that as we go throughout. But we're going to stick in C# to keep things kind of simple. But that is truth, and you can take that to the bank. So, all right. Don't forget to submit evals. You're welcome to do it now if you're feeling good. If you're skeptical, wait till the end, okay? But don't do it now. That's okay. Just forget the slide was here. So, it's been a really big year. We were here last year. Mads and I were up here just last year, and it was an exciting time for us. Who remembers that last year? We did some really cool things. We started talking about C# 6. We had done a couple of talks here and there at various smaller conferences to just start, testing the waters. And then we came here and really gave a big reveal about what we were thinking about, what we were looking at, talked about some experimental features, and what might end up in the language at that time, what our thinking was. We also, last year, we released the .NET Compiler Platform, or Project Roslyn. We released that on open source on Codeplex. And also shipped an end-user preview and an SDK preview. And really, it was kind of us coming up for air. We had been laser-focused on this thing for a number of years and finally coming up for air. And then this past year, we have been completely breathing oxygen free and clear in the world. And we have taken the time. We have refined the set of C# language features. We're going to talk about that today to show you what's actually in. Perhaps maybe mention a few guys that didn't make the cut. But really what the cohesive set of features that make up C# 6 and make it what it is. We're going to talk about that today. We're also going to, we should mention that since then we've also shipped like a number of times, like 8 times. We shipped 6 public Visual Studio 2015 CTPs. We shipped a preview in November. We shipped an RC the other day. So we've been shipping like crazy since then, and that's been helping in this refining process. We released the .NET Core libraries and runtime as OSS on GitHub. That was a big step as well. We had released in April, we'd released Roslyn, and then in November, the .NET Core guys went up on GitHub, kind of paving the way for us in January to move to GitHub, which has been very exciting. So it's been a big year for us as well. And finally, we open sourced the remainder of our Roslyn code base on GitHub. When we went out last year, it was just the compilers, just the APIs, on top of those compilers. But now we've released the entire stack, the entire language stack of the IDEs. We released scripting APIs, an interactive window, and this current state of all those projects that kind of under the Roslyn umbrella. And so it's been a really, really big year. Yes.
Huge.
Huge.
Yes.
Huge. It's been a lot of fun. And so we kind of want to just talk about some of that today. We want to share what C# is going to look like. When you get into Visual Studio, what is C# 6? What is Visual Basic 14 going to feel like when you get in there? So we want to talk about IDE features. We want to talk about analyzers and code fixes, which is a huge topic of some of the really the features coming out of the work we did in Project Roslyn to put static analysis in the IDE and in your build system. We're going to talk about the new language features, of course. We have to do that, and that is the most important thing. We're going to talk about some debugging features we've done. I think it's the most important.
It's the title of the talk.
It is the title of the talk, yes. And then we're going to take a peek at what's next. I walked around and talked to a few of you beforehand, and everybody was like, I was like, what do you want to hear? And they're like, C# 7. Tell us what C# 7 is like. And so we'll talk a little bit about that, though, to be fair, we don't have a lot of secrets these days. All that going on GitHub means that a lot of that information is there and you can be involved in the discussion, and we'll talk about some of that as well. All right, so let us dig in.
You're on.
All right. So this is Visual Studio 2015 RC. This is, I'm going to talk about some of these IDE features. This looks exactly like Visual Studio 2013. It is a completely boring demo. If you have tried out Visual Studio 2015, though, you know that's not true. This is completely rebuilt from scratch from Visual Studio 2013, bringing in a brand new IDE, brand new language service and editing experience for C# and Visual Basic. And so what you'll see here, you'll see it looks very similar, but as you work with the IDE, you're going to find things that are just a little bit different. As we took the time to rebuild some of these features and rethink them, some of the features now look a little bit better. They've been refreshed. And so, for example, if I hover over variables, you'll see things like, things look colorful now, right? There's little glyphs that appear. It's all very fancy. Little pieces of color. It's even something so mundane as, for example, if I collapse an outlining region, something that's been in the product since the beginning, since Visual Studio.NET 2002, actually. Outlining, if I hover over that, you see all of the rich semantic information of the syntax highlighting underneath and inside of there. So just taking the time to make things a little bit better. Now, interestingly, if I come up here, though, we've done some things a bit different. And this is kind of the experience that people start seeing immediately. You start seeing things like faded using directives, where basically we've taken something that comes from in other modern IDEs, a feature that's very commonly seen across other IDEs, and we wanted to bring it into Visual Studio. So some of these using directives are faded out because they are unnecessary. Now, as you move around the IDE, and you find things that are faded out, and it starts telling you things, small things, warnings, errors, and faded code, there's a little light bulb that appears over here. If I click on that light bulb, it gives me actions I can do. And those actions come with a really sweet preview that's a diff preview showing you what will happen to your code if you were to do this. It's like we're taking a snapshot into the future, looking into the future, and figuring out what your code base is going to look like and giving you a picture of that. It's very cool. So what's also cool about this, though, down here at the very bottom of this preview window, you'll see a couple of commands. Preview changes, document, project, setting. You can fix all occurrences in those scopes. So if I click on project, for the first time, we can, there we go. We can remove all unused usings across the project, right, or across a solution. And so I can apply this. If you look over in the Solution Explorer, you see right now that there are no changes, but then you start seeing check marks where changes occurred. And I can undo, and you see them go away, see them come back, go away, come back. It's cool. It's exciting. Now, as we go through the IDE and you start seeing some of these things pop up, the light bulb appears. Sometimes you want to do a transformation, a refactoring or something to your code as you're walking through. You see something you want to change. And it's not real obvious how to get the light bulb to appear. The light bulb has a keyboard shortcut. It's an important shortcut. Maybe the most important shortcut in the product is Control Dot. That'll always bring up the light bulb. And if I select an expression, say I want to do something with this expression, maybe introduce a local variable for it, I press Control Dot. That'll bring up the light bulb with that great preview. So I can see that down here telling me what it's going to do. Bring that up, introduce a local. And then I'm put into yet another new experience as part of Visual Studio 2015. When we went back through and we started re-implementing some of these features, like the rename refactoring, we realized that we didn't want to do it at all like it was before. If you remember rename, you press F2 or Control RR on a symbol, and it pops up a modal dialog and lets you type in a new name, and then you can wait while the dialog comes up and makes the changes. And it's not really a fluid thing. It kind of takes you out of your coding. We want to keep you right in the editor, in the coding, fluid like you're used to doing. And so this local is given an initial name, but you see that there's a field linked to it down below. And as I type, it changes all across the editor, so I can see where my changes are occurring and what's affected in the file. And of course, even if I were to make a conflict, so notice up in the dashboard up in the top right, it says there's one unresolvable conflict. That's down here, down at the very bottom of the file. See the routine down here? There's already a variable called routine, and so this would be a conflict that would break my program. We just want to let you know about that, right? Giving you kind of ambient information as you're typing, as you're using the features, keeping your program working. So we're not going to actually stop you from doing this. You could very be very well trying to do this as a stepping stone to some larger refactoring, and so this might be exactly what you want to do. So it's okay to apply it here, but I'm not going to. I'm going to keep on typing. I'm going to change it to something else, and I'm going to change it to the name that's right below it. There's a field called routines offset. So come down here, and this time there's a conflict, but it's resolvable. Right? This is something we could just fix for you automatically. You see, so it already, because there's a field called routines offset, it inserts the this dot for you.
Hey, is that cool
That
or
is
what?
cool. This is a piece of the IDE now that is also extensible. The idea of doing code refactorings is an extensible thing that's built on top of Roslyn. And that idea of doing smart refactorings that fix conflicts for you, there's a whole system built around that. This dot is child's play. It does some crazy things to make sure that your program stays correct with regard, at least to the semantics as defined by the language. So that's just one example. We have a couple other refactorings in here today. That was a new refactoring for the product, introduced local. People have been asking for it for years. The opposite of that is inline temporary variable. So I'll press Control dot again. And this one takes that expression that's assigned to the local and inserts it wherever the local is used, removing the local after it's done. And so you can see here in the preview that that's exactly what it's going to do. It's going to remove it. It's going to put the expression memory.readWord right in there. So I'll go ahead and apply that. Now this time, though, what's interesting is that the this dot is faded now because it's no longer necessary, right? Because I no longer have a local that conflicts with its name. So it fades that out for me in the editor, and I press Control dot, and there we go. So that's just kind of a quick look at some of the new IDE features and what the experiences you're going to have. Let's take a look at something, though, a little more meaningful from the perspective of how we're going to, how we envision this static analysis and code fixes and how we want to expose this to you guys in the ecosystem as you use libraries. So I've got a pretty simple application here, extremely simple, demo fodder, I would say. And what it does is it news up a couple of arrays, and it checks their length, right? So most of you should be able to tell me what this does just by staring at the program. You can envision exactly what it's going to do. I'm going to press F5 to prove it. It prints the length of 2 arrays. We created an empty array, and we created an array of 5 elements, and then we printed them. So I'm a new developer, maybe, that's interested in the .NET immutable collection. And I've used arrays before, and so I know how those work. I can new them up, and I can check their lengths, and everything's good. However, and so I start using the immutable arrays. Let me just paint this a picture. And immutable arrays it's part of the system.collections.immutable NuGet package that's available. It's open source on GitHub. It's part of .NET Core, part of the CoreFX project. And so kind of the equivalent code, newing up an empty array, I would try and do something like this. I would just new it up, right? And then likewise over here, I would just kind of new it up, and I'd use a collection initializer. It looks very similar to this code right here and right here. So I try and just kind of reuse what I know works. And so let's try that. I'll F5, and it explodes. And that's not very good. And the reason it explodes is because of some nuance to the API. Immutable array is a value type. And the way it works, the purpose of it is to wrap around existing arrays, providing kind of a read-only and immutable interface into a .NET array. So if I just new it up, it's not going to have anything in it. In fact, because it's a value type, it has to have a public parameterless constructor. It's generated automatically for you. And so it's kind of there as, normally that's something that helps you when you're using a struct. In this case, because of the way the API is structured, it's actually a hindrance. If you didn't have to new it up, or if you couldn't new it up, you might not run into this problem. Likewise, down here, it's a similar problem, where it's going to new up that constructor. However, there's another problem in that even if we could construct it, suppose there was a constructor that did the right thing, the collection initializer won't do the right thing. If you remember how C# collection initializers work, basically those break down to calls to an add method, right? But because this is an immutable array, those add methods return new immutable arrays. And so when you get down to the end of it, even if this actually constructed an empty array and called the add method 5 times, you would wind up with an empty array, right? So these are things that are perhaps there's guidance here we could offer that we would like to bake into the compiler, maybe, but this is kind of chasing after, doing this for every type in the .NET framework is really chasing after kind of a long tail of things. And so by exposing the analyzer framework in Roslyn with something we call code-aware libraries, we can go to we can build those analyzers and put them in NuGet packages or in Visual Studio in V6s and make those appear. So I just put this up there yesterday, up on NuGet. I put up a project called Core FX Analyzers. I'm going to install it. Right now, it just has 2 analyzers. Okay? Sorry.
Just to make it very clear, when he says we can build, he does not mean we, Microsoft. He means anyone.
I mean, everybody in this room, myself included, I see this project. I'd love
people
for
watching
anybody to come
online.
join. Anybody online, future Dustin, if you're watching this later, feel free to remember to go and also contribute to this project. So what these analyzers do, when I add this NuGet project, it adds Core FX Analyzers under the Analyzers node in the Solution Explorer. And under here, under this node, there are 2 brand new analyzers. There is one to not use an immutable array of T constructor and do not use a collection initializer with immutable array of T. I brought that in through NuGet, which means actually because these are installed via NuGet, the system.collections.immutable package itself could carry along this guidance so that when I install it, I get squiggles in the editor. I can also include code fixes with it. Right? So the correct usage should be to do an immutable array and call empty. Right? That's what you want to start with. You don't want to call the default constructor. So we can do that. We can come here, fix this one. This one I need to call create range to pass in my initializer. And then when I run, it works. Okay? So this is the sort of thing what we envision kind of the world of libraries and frameworks going to, where they can carry along guidance to help you use those APIs. So in the session after this, I'm going to show how to build exactly these things. And so I'm going to step away from this right now. And you know what? It's time to talk about language features. I think everybody's ready to talk about language features.
It is.
All right.
So Dustin showed analyzers. And he actually wrote an analyzer also called C# Essentials, which will help people get started using the new language features. And I have that enabled here, so we'll run into that a few times. Before I dive in, the philosophy for C# 6 was very much also this refresh theme, if you will. We were so excited to now have a completely fresh compiler code base that we weren't scared of, that we wanted to go and do a lot of those little features that we hadn't really been able to get to before. They were too risky or whatever. So now we said, this is not the time to introduce some big new concept that everybody has to change the structure of all their code, like async. We don't have any of those lined up. We should do little things that will make your code nicer in little but useful ways. Okay? So we have tons of those. And that's what I'm going to just tear through and show you a bunch of.
Just to be clear, though, did everybody want us to tear the language apart and build it back up again this time, like last time and the time before?
What?
I don't think so. They wanted the little features, right?
I think so. That's what we've been hearing.
Yeah.
Yes.
That's what we've been hearing.
So we've been going through and finding the little features that made most sense to us and that a lot of people have been asking for. So again, I have what is very clearly a demo program here. It creates some points of a point class I have, writes them out, turns them into JSON, writes out the JSON, turns the JSON back into an array of points, and writes it out. Okay. So I'm going to run it just once so you know that it's what it's doing. And other than that, runtime semantics aren't really very interesting in this talk. It's all about what the code looks like. So to start somewhere, one of the things that people have been bugging us with for a long time, and that's been a nuisance to us also, is this necessity to always mention a static class explicitly when you access static members, to always have to mention an enum type explicitly when you access its members, and so on. So we said, OK, now it's time to add a kind of using clause that you can put these guys directly into scope. So now you can say using static, which means use the static members of, for instance, system.console here. And you see it's gray because I'm not using it, but console is now also grayed out. And the IDE will helpfully tell me that I can simplify accesses of console to write line to just say write line. So I'll actually do that in the whole document and apply all of these, and now I can just say write line. Okay? Is that going to help a little? It's cleanup time. All right. So you typically use this for you often use it for static classes. They're always collections of functions that you want to use, and oftentimes it makes sense to put them into scope, like system.math, for instance, also. I know I have an instance of that inside of my point class here, which we'll dive into more. So you see down here, math.square root. Again, I can go and just get rid of the math. Get rid of the word math. The math is still there. So you can use this. You can overuse it. I think sometimes it'll be really nice to get, days of the week or whatever, enum values directly in scope, but you can also overdo it. I'm doing some JSON stuff later down here, so it might be tempting to go and say newtonsoft.json.link. Get those JToken types just directly in scope here. But you can also quickly get a bunch of names in scope. There's a JToken type called string, and now I have a conflict here on string.format. So I'm not going to do that. But just to show you that, yes, you can get a lot of abbreviation here. You can also get too much if you're not careful. So that was that feature there. Looking further at the class point here, we, like everybody else, have gotten really, really fond of immutable types, right? And all our data structures in Roslyn are immutable. Dustin just showed immutable collections and so on.
Stuff, yeah.
However, if you are wanting to build your own immutable types, we've been treating you badly in the language. We've been sort of preferential to people writing mutable types. For instance, auto properties could only be get set properties, and so here I would have to write my properties with explicit backing fields. Well, no more, because now we do have getter-only auto properties. You can just write get, semicolon, and you have an auto property with a backing field that is read-only. And in order to initialize these, you can assign to them from the constructor directly. So I can just assign to x here, and that assigns to the backing field. I can assign to y here as soon as I go and change that also into an auto property. And so now you're not discouraged from using immutable patterns in your code. I can just go and remove my backing fields and just use getter-only auto properties. Thank you.
And for my next trick.
And for my next trick. One more. Let's do one more on auto props, is what we said. So another annoying thing about auto properties is that unlike fields, you couldn't initialize them directly. Well, now you can. So you can say equals 5 here, just like you can in a field. And that will initialize the backing field again. And that, of course, that works for the existing get set auto properties as well. I'm not going to do that, though, here, because I really like what's coming in through my constructor there. So a few other things in terms of member declarations that may be a little bloated. It's a little hard to get to the logic for all the boilerplate here. Our good friends in the functional world have known this for a long time, like F#, for instance. We sort of know it from lambdas. Sometimes your result is just expressible with a single expression, and why do you have to have a statement block with a return statement in it? So lambdas today, you can choose either to have a statement block or you can have just an expression body. And now you can do that also for methods and for other function members. So this is where Dustin's little helper analyzer comes in. It's actually suggesting this to me. If you notice, the curlies and the return are grayed out here, and that is Dustin's analyzer telling me that I should consider using an expression-bodied member. And so I'm an adventurous guy, so I'm going to go do that. And what it's going to do is to, shift focus on the screen here, but other than that, it is going to put what people would probably have called a lambda arrow, or fat arrow. I think we should call it the function arrow now. Put that there, put an expression, and that is now the body of the method. So we have expression-bodied methods, okay? And that should, now for simple stuff, like say you have some operator overloads, lots of things that are simple methods, should be nice to just be able to inline them like that, not have all the extra boilerplate. For getters, for properties, it gets a little better. When you have computed properties, a getter, single return statement, even more boilerplate there. Again, we're going to go and just let you use an expression-bodied member, and that takes away everything. The curlies, the get keyword, and you just really have to put the arrow and the expression that is the result of the getter. And that way, again, it gets very concise. Again, this can be overdone. Thank you. I would personally recommend against carefully turning all your logic into a single expression so that you can do this. That kind of defeats the purpose. I know I've overdone that myself.
This, though, Mads, I should say, this has become my favorite feature. I didn't know that it would be, but it's
Right.
definitely become my favorite
It's a
feature.
bit of a surprise hit,
Yes.
I have to say.
Yeah.
But it's just like get all that extra stuff out of the way, get room for more logic on your screen, really. So let's keep going on that theme. Dustin is not finished with me here in this method. He's also saying something else. He's saying this can be simplified.
Well, that's
I have to click there, I think. When does this kick in, Dustin? Yes, he says I can convert this call of system.string to what is called an interpolated string, or string.format into an interpolated string. So string.format is great. It can do all kinds of stuff for you, but it's a little bloated to look at, and in particular, what's not nice about it is these placeholders, you kind of have to keep them in sync with some argument that come a lot later, and that can easily create bugs, and it's not easy to read. So we decided to just build it into the language. So now I'm going to convert this to what we call an interpolated string. So this is equivalent to what I had before. All right? Put a little $ in front of your string literal here. We had to use a $ for something sooner or later. So in honor of Visual Basic, we're going to use $ to mean something with strings. And of course, this is one of most of the features I've showed you, also in VB, not the expression body members, but the getter-only auto properties. This, of course, is also in VB. What's happening here really is that you still have your format string here, but instead of having placeholders in the holes between the curlies, you now have expressions. Like you can put any old expression in here. It's a hole in the string. You can put real stuff in there, compute it. And you can also, so if I wanted to put something longer, you know, system dot day of week dot something or other, dot Friday, turn that into an int, whatever. You can totally put any kind of expression in there. You can also put the format, the alignment specifiers and format specifiers that you can in system.string or in string.format. Okay, so it's as general, but it's just much nicer to look at. I hope you think so too. Do you think so too? Yes, you do. Thank you. Someone up there doesn't. Let's talk after. Here's sort of half of the heart of my functionality here. I'm turning a JSON object, a J object, into a point. Okay. If it doesn't have the right shape, I can't. So I'm going to throw an argument exception. And one thing you'll see here is that Dustin is telling me I have the argument name as a string. So he has an analyzer that discovers that he wrote and put into his set of analyzers here. And it says, this is dangerous. Why is it dangerous? Well, if I change the name, for instance, let's use this new lovely rename refactoring, and I say, oh, let's call this arg instead or something. Of course, we will forget to change the name down here, and it's going to go out of whack. If you use it with iNotify property change and so on, that actually causes errors. Right here, it's just a cosmetic, you could say, but still, you want to get the right name in there. And so what Dustin says is use this new feature called nameof.
I'm right on your shoulder right here, whispering in your ear. Dustin says, do this, do this.
Yeah. I have Dustin in a box.
Yeah.
How cool is that? So let's go do it here. Consider using nameof. Yes, I will. Oh, I did not do that.
Cancel your rename. Escape out of your rename.
There you are. Oh, you're right. Yes, I'm...
Dustin's on your shoulder telling you to escape.
Dustin,
there you go.
thank you. I needed the real Dustin for that, though. I wasn't listening to the one in the box. OK, here we go. Consider using nameof. Why is it not? Oh, here we are. OK. And so nameof is really just a string literal. It just compiles down to the string that was there before. But it checks that the name... You like it?
Wow.
It's the simplest feature in the world. It's a longer string literal that will give you errors. Like, how cool is that? But somehow it is cool, because now if I rename it, of course, it works with the other guys. And it'll give you errors if I have a typo in here and so on. So that's just, again, a surprise little thing that just really helps you. Of course, it doesn't have to be an argument name. I could go and make this. I'm referring to the class name here. We could make this an interpolated string. We could put a hole in here, and we could take the name of point. And that way, we make sure that if we change the name of the class, like we could here, then we would actually go and fix it up everywhere as well. So those two features work nicely together. I also want to call attention to this block of condition here. This is where I check that my JSON is in the right shape to form a point out of. Okay, so first I have to check that the argument itself is not null. If it isn't, then I'll index into X and see if there is one, or whether that's null. And if it isn't, then I'll make sure that its type is indeed an integer. And this is where I use the JToken type integer. And then do the same again for Y. And so that's a lot of logic, and most of it is about checking for null. And isn't that just annoying? Yes, yes, that is very annoying. Thank you. So what we decided is to smooth that over in a few common cases. So instead of checking here that this is null, I can use the null conditional dot, or the question dot, or also, oh, that was not a question mark. Also, sometimes affectionately known as the Elvis operator, because it's got two eyes and it's got this swirl of hair that is not particularly Elvis-y, but no. Hey, everybody knows Elvis, right? And it's cool to have something named after him. So what that means is that we are going to see if the thing on the left-hand side here is null. And if it is, then we're not going to do the dot. Then the whole expression here is just going to be null, which is not a JToken type integer, so it's going to fail as appropriate. If it isn't null, then we're going to dot and get the value out. So it's just an inline null check, if you will. All right? And so we can kill that line of code. And with another question mark, we can kill another line of code. And it's like a real bloodbath here. We can also do it for indexing. So I don't even have to check up there that JSON itself is null. I can say question mark in front here as well. And that means if it isn't null, then do the indexing. Otherwise, the whole thing becomes null, right? And so I really just, again, I boiled it down to, let's get rid of all the boilerplate. Let's just have the core intent here, which is if the point hasn't got x's and y's that are integers, then throw the exception. OK? There's just the core logic is in there. Glad you like it. So let's see. We have time for another one. Yeah. We can go. We can go a little longer.
That's what they're here for.
So let's look at the method that takes. So that was sort of the big ones. Let's look at a few smaller ones that, to some of you, may also be significant. This is the method that takes you from the point back to JSON. Okay. So the inverse of what we just saw. If JSON had real members called x and y, we would have used an object initializer here, which we've had since C#3. We've just set something like x equals capital X or something like that, comma, and the same for y. It would all have been one expression declaratively initialized. But because they're initialized through an indexer, that hasn't been possible before, but it is now, as you were probably already guessing here as I was leading up to it. So you can now initialize to an index as well if you can actually hit the right keys. So you could do this. And y is y. And now the j object is initialized in one fell swoop in the expression here. So just alongside your member initializers and object initializers, you can now also initialize elements, which of course means I can go and
control dot, inline temporary
control
variable.
dot here,
Yes.
inline temporary variable. Well,
Yes.
That's nice. Oh, it turned gray. Well, that is Dustin again telling me, wow, this could be an expression-bodied member. And of course, now it all became very smooth and succinct here. Dustin, ladies and gentlemen. We can talk about a few more things quickly around exceptions. So this is a method. I'm not actually using it here in the main program, but let's look at it anyway. This is a method that has a try-catch in it, and it's an async method. Okay, try-catch finally here, and we have to admit that there was a hole in our implementation of await, that await couldn't be used in catch and finally blocks before, because we thought, oh my God, we don't know how that would even work. I guess we weren't as smart back then.
Future yourselves were smarter.
Yeah, we turned out to become smarter with time. And so after we shipped C#5, we were like, we can figure this out. Like people run into the need I want to log something asynchronously down here in my catch block. I want to say there was an exception, log it somewhere. But if I say repository.log, well, there's a log method, but it's async. Well, that sucks because I want to actually not exit the catch block before I'm done. So how do I do that? People have terrible workarounds for this. And we're like, we should do the terrible workaround in the compiler rather than everybody doing it every time, right? That's what we're here for. Let's actually earn our keep here. And so now you can indeed await inside of a catch block, and it just works. It just doesn't. It doesn't exit before it's done. And even better in the finally block. Oh my God, is that difficult to work around? Repository that, let's say I want to close the thing here after, I can now await doing that asynchronously. And you don't come out of the finally block until you're actually done, which is what a finally block is supposed to be for. So very nice. One little extra feature, which is already in VB, we added to C# as well. It's actually also in F#. The ability to filter exceptions, which is a tiny little feature, but it's actually kind of nice sometimes. So I can put a condition on a catch block and say, I only want to do this when, say, some bogus thing here, e.occurrences is greater than 3. Otherwise, don't catch it. Don't even touch it, OK? And it's sort of like putting an if block inside of the catch block and rethrowing, but it's different because the exception doesn't get modified. It doesn't get its origin, point of origin, overridden, right? So it just keeps flying, and it doesn't. The final receiver of the exception can see where did this really originate, rather than it having been caught and rethrown. It's also popular for dirty tricks, yes. Like having exception filters that always are false, like they never catch the exception, but they log something along the way, or tricks like that.
Or only catch it on Tuesdays.
Oh, catch it on Tuesdays, yes. Yeah. But no, that's not a dirty trick. That's legit. So that's it. Those are the main features of C#6. There are a few tiny ones that we may or may not that you may or may not discover, but these are the bigger ones. So I hope you like it.
Cool.
Now, we can debug this stuff as well, right?
We can debug this stuff. We're going to switch over to my machine to do a little bit of, look at a few of the debugging features. But it's kind of a sorted story. I'm going to continue with this code because the story of debugging of C# code, at least when it came to language features, is a sad one. Chris Dias up here remembers that in Visual Studio 2005, we brought back edit and continue. Right? We did a bunch of work for edit and continue for Visual Basic. It had been taken away from Visual Basic users. We brought it back in 2005. And we brought it to C#. And then we continued to evolve the language and failed to evolve the edit and continue, such that every time you tried to use a new language feature, you would stub your toe and it would say, sorry, you can't actually edit this code at debug time. To the point that now, it's almost impossible to find places in 2013 that you can really actually meaningfully use edit and continue to write an application. So we decided that with rebuilding kind of the entire stack here, that we wanted to address that and make it so that no language feature is left behind, and you can do these sorts of things. So I'm going to set a breakpoint, and I'm going to try to do some edit and continue. So let's see here. What should I do? I'm going to create a list, and some of these things are things you can do today. Okay, I can create lists. I could do that sort of thing pretty easily today. What I couldn't do before is press Control dot here at debug time and generate that class. Okay, that works. It's down here. There is no purple squiggle. Okay, this doesn't work. Now I want to populate that. I've got the person class, so that's good. So let's go ahead and let's throw a person in here. We'll set some properties that don't exist yet. And I can just start exploring at debug time and changing my application. Right? We'll say Mads. We'll do like eye color. Oh, well, they're a lovely shade of brown.
Thank you.
Okay. We need a
just for the people in the back who can't see it.
Right. We need a semicolon down here. And again, I'm going to press Control dot to generate the property for my name. We're going to go ahead and actually, I can hover over this as well, I think. There we go. We're going to generate a new type. Now, this gives me a lot of options because it doesn't know what I want to do with this yet. So I'm going to generate a new type. And we're going to come in here. We're going to make this an enum type. Whoops, there we go. And that got added down here as well. Okay, we're going to add our enum member to that. So you can see it's got a preview. It's going to add brown into the enum. And we'll generate our iColor property. And right now, if I look at the error list, there are no errors. There are no squiggles. There's no purple squiggles. I am still debugging this program. I stopped it at a breakpoint, I swear. Okay? I know you don't believe me, right? Because this has never worked. So I'm going to add another one. We'll add myself in here. And you can see IntelliSense picking everything up because they're actually there in the file. I can't type my own name.
This morning, they're blue.
Oh, yes, mine are blue. A lovely shade of blue. So we'll go ahead and generate that enum member. All right, and I can step over this, and lo and behold, sure. I've got, in my list, I've got 2 person instances of person, their properties set, everything's there. There are staggering things you can do at editing continued time now. For example, if I just wanted to get the, I don't know, let's get the people with blue eyes. So there's just, blue eyes. I could do things like this. I believe I can do things like this. We'll see if this works. I just want to get myself and my name. There we go. And that, if I come back up here, I can move the instruction pointer. Control-Shift F10, by the way, moves the instruction pointer, has for years. Great shortcut to know. Step over that, and sure enough, I've done a link expression at editing continue time, which, if you know the machinery underneath link expressions, it's done crazy things under the hood in order to construct lambdas and all of that business and captures and everything. So this is very, very cool. Now, as I said, no language feature left behind, right? And edit and continue is great. Sometimes I don't want to edit and continue. Very often, that's not what I'm doing. Very often, I just want to introspect a little bit further into the stuff the types and values that I already have in my program. And often, that's very hard. For example, if I wanted to find the person with blue eyes from a watch, that would be difficult. That is no longer difficult. The reason it would be difficult is because I couldn't pass a lambda in here. I'd have to have one, right? And sure enough, there it is. Or I can come over to the immediate window and do the same thing. p.icolor. Whoops. I have to type things right in the immediate window, though. There we go. Or IntelliSense doesn't help me. There you go. So really taking the time to rethink the debugging space, to make sure that the breadth of the language is available here. So all the things that Mads showed you that are really work in expressions, like question dot, those things work in the debugging windows now. And in the RC, this is the Visual Studio RC, so this is working today. We have more to do here, and we're continuing to try it out and try and get as much as we can packed in for RTM. So try it out, give feedback. We'd love to hear, so that we can smooth out the edges and make sure we have everything that's possible to get actually working. All right. Now, before we go on to some future-y things, and we are going to go on to some future-y things, I want to mention, Mads used this C# Essentials tool. I just want to mention very quickly, if you're interested in trying that out, you can get that from extensions and updates in Visual Studio. You can go to the online tab, and you can just search for C# Essentials, is what it's called. And it will show up right here, okay? And that'll give you some analyzers and refactorings and fixes for taking code and seeing where a C#6 feature could remove some boilerplate and make your program more concise, easier to read, that sort of thing. So, okay, now last but not least, we wanted to look at a few things kind of dialed into the future. And so I'm going to bring up something that we haven't brought up in a while. It's been a few years. So I'm going to go to Other Windows. I'm going to bring up the C# Interactive window.
Yeah. We
haven't seen this in a long time. In fact, we haven't seen it in so long that many of you maybe have not seen it at all. But the C# Interactive window is kind of a scratch pad or a place where I can go and explore C# code. I can play around and explore APIs. And what it really is, though, to me, is it's the world's most inefficient, overly glorified calculator, right? So I can just come in here and type expressions that would be C#. And the amount of effort and compute power to do that was just insane. We wasted cycles like you wouldn't believe to add 2 plus 2. But I can do other things. I can do interesting things as well. I'm going to go and add a couple of references. We can add the #R directive here to add references into the system. I'm going to add a couple of references that aren't there by default. Let's go ahead and add a few namespaces. So I'm going to say using system diagnostics and system.link. Now, this is not in the RC. Okay? This is something that we stopped working on for a while. We had really forged pretty far ahead with it, and we stopped working on it for a while. And this is something that we have a roadmap to go and invest in very soon. So following RTM, we have a roadmap up on our GitHub project that you can go check out. We post our design notes from the interactive group that's working in this window and working on the entire REPL and scripting story on GitHub. So definitely check that out if you're interested. But it's this really cool thing, and it relates to debugging because part of the roadmap is that we want this to be part of the debugging experience. Today, it's kind of a separate thing where you get kind of a separate little universe where you can play with some C# code, construct some objects, and play with them. It would be great if I could take that and then apply it and use it right on my application, my running application.
Oh, Dustin,
yeah.
You said a strange word in there. You said something that sounded like REPL.
Oh, REPL, the read-eval print loop. Yeah, that's us marching boldly into like 1958, right? Putting a read-eval print loop into C#.
Just in case people don't have that
yes.
Abbreviation in their vocabulary anymore.
Yeah, so I'm going to go ahead and I'm going to type some code like the sorts of things you could do in here. Let's say we want to find the memory pigs on this machine. Right, find the processes maybe that are running with more memory. So I'm going to use a link here. I'm going to, and what's cool about the REPL is that it's not your parents' REPL or your grandparents' REPL. It's got full IntelliSense, full colorization. Quick fixes will work in here. Gray things will gray out. All of that. The same experience that you get in the editor will work inside the REPL. So get all the processes here. Say where the p.working set 64 is greater than what's a cheap way to say megabyte? Here we go. And then I will select an anonymous type with the process name and the working set. That looks like I typed it right. And so now that's what I've got in memory pigs. I can for each through that. I can use statements at the top level here. And so we'll say for each pig in memory pigs. I'm getting things like, autocomplete for braces, curly braces, and all that sort of features you expect in IntelliSense. And we'll do, actually, I forgot to use system. Using system.writeLine, and we'll pass in pig. There we go. And you can see what the processes are that are killing me on my machine. Oh, there's devenv. Yeah. I don't know why link needs that much memory. But anyways, so that's just a quick look. This is still here. This is still something we're working on. It is up on GitHub. The sources are there. You can build them yourselves. You can install into the product. It's not that hard to do. I did it just yesterday to put it in here. So that's just a brief look at that. You had some stuff you wanted to share as well, right?
Yeah. We should give Dustin some applause first, though. Obviously, when this gets online, it's also a great way of exploring new language features because, again, like in Edit and Continue, they're going to actually work everywhere.
Yeah.
That's kind of our new style, actually make things work. I really like that. So let me go and switch over to, and I apologize.
I've got you on there.
You got me. Thank you. This is Chrome.
That's what I do.
Yeah, I know.
I'm always here for you.
GitHub works a little better in Chrome. That's sort of the near future. Like soon after RTM-ish is where we're targeting the REPL starting to come online and then start getting better from then. In the sort of further future, we realized back around January that if we want to start thinking about a next version of C# after C# 6, now's a good time to start thinking. While most of the team are still working on VS 2015 Wave stuff, now's the time to start the thinking. And as we went open source with our code bases and took all those implementation level discussions open source, we've also gone open source with our language design process. Okay? So we still sit around in rooms and have language design meetings, but then I go type up notes from that and I put them out on on GitHub.
Whoa,
It used to be
whoa.
Codeplex. If you want to see the design notes for C# 6, Codeplex is where you go. I put them out on GitHub, and people put, so GitHub, we're here on GitHub. If we look at, let's see, this one here, I filtered for design notes. These are notes from the language design meetings since January. Just all out there with all our discussion about what should possibly be in C# 7. What are the kind of themes we might want to focus on? What could the shapes be of features? And it's all very nebulous right now. It's in the cloud, but also in other ways nebulous. Like, what will the final themes be? But some things are starting to crystallize. And it might be one of those situations where future Mads looks back and said, oh, you thought you were going to do that for C# 7? But we started the process. And so I really encourage you to go out on GitHub, actually start putting up your own language proposals. We have, let's have a look here. We have currently 136 open language proposals just since January on GitHub that we will look at in time and that there's discussion about. Of course, people discuss like crazy the designs that we put up, and we get tons of good feedback. So we're kind of in this loop with everyone all the way, rather than sort of put something out after a year or 2 years and seeing if it sticks. And it's really helping us, I think, home in on the right things. So we're pretty, right now we have a pretty ambitious kind of plan for C# 7. We want to do many things, and we want to do big things. This may peter out, it may not, but that's we're sort of going boldly in. And one of the things that we want to do, and one of the reasons we started so early, is that we want to try to attack some of the big problems that we've attacked before and failed, okay? Or that have really become big problems over the last couple of years. The language world is evolving. It is now no longer esoteric to think about nullability tracking in your language. It's no longer esoteric to have tuples in a mainstream language. A lot of things that have been in great languages like F# and other functional languages for a while, but never really made it into the mainstream, they're starting to move into the mainstream, and people are starting to be ready for them. And so now it's time for us to think about it again. And so what I have here, for instance, is sort of a work list of the features that we have ever looked at in this round of design, and kind of bucketed it into which ones are we interested in. We're certainly interested in nullability, like tracking whether a field is intended to be sometimes null or intended not to be, and then checking your code to see if you're adhering to that. Tony Hoare called the null pointer his $1 billion mistakes. We will try to get you back about half of that billion. Okay, so that's sort of the ambition. All of this tracks proposals in here. Tuples is another one that we're interested in, and I think the main scenario for that is that in a language like C#, there's an asymmetry. When you look at functions, for instance, so this is a proposal that's out on GitHub. You should go look. There's an asymmetry between input and output to a function. You can take several things in, but you can only give one thing out. And we kind of want to restore that feeling of symmetry, that you can also have multiple results. And so the approach we're taking to tuples is that it looks something like this. Here's a tuple type in return position. It has components consisting of type and name, just like parameter lists. So we're kind of using parameter lists as the analogy there. This is something we want to do. We want to enable you to write tuple literals, so you can return. When you have this return type here, you can return say a pair of values here, and they get typed by that tuple here. You can deconstruct tuples. So at the receiving side, where I call tally, I get this tuple back. I can immediately deconstruct it into its component values and so on. And then we put that up there. We discuss what are the pros and cons, how can we implement it, and people just swarm here with commentary, and it's good. It's really good feedback. It's people who have experience and deep thoughts and so on, and that helps guide our design process. So let's go back to the work list here and just quickly look at some of the things that are on top here. I talked about tuples. I talked about nullability. Another thing that we're talking about is pattern matching. and we're talking about sort of records or algebraic data types. Those two kind of go together a little bit. One of the things that we find is that in traditional object-oriented programming that C# was kind of built for, you put a lot of your functionality on the inside of the objects. The object, classes have hierarchies, and in hierarchies you override virtual methods, and the objects know what they can do. And that's a great paradigm for a lot of things. But one thing it's not so good for is if your objects represent data that exists in multiple contexts, that's sent over the wire and is used differently in different places. Like I might use the data differently on a service in the cloud than I use it on the device that pulls down the data and so on. So having the functionality wrapped up with the data doesn't make sense at this point. You want to have functionality on the outside. Functional languages are good for that. And the way they then distinguish, so we're borrowing from those. Look at F# and other functional languages for inspiration. And what you want to do there is to write a function that is able to essentially switch over the shape of the object. Say, is it one of these, then do that. Is it one of these, then do that. And pattern matching is a mechanism for doing that succinctly and beautifully. So we're taking these things as inspiration from, say, F#, trying to figure out how can they look good in a C# context. How can we make them feel native to C#? It's not like some transplant from another world. And that's the process that we're going through right now. I encourage you to go here, look, give feedback, help us get the right plan for C#7, even though it may be years before it's actually reality. Even though it might not be called C#7, who knows? So please do that. That's as far as we are with that. So now is where we're going to switch back to slides for a second here. I can just click here. So while I say a few things, we're going to have a little bit of Q&A. We would like you to come to the microphones if you have a question, and you can start going up there, and we'll have time for 1 or 2 questions maybe. And then after the session ends, I'll hang around here and answer a few more questions, though they'll probably throw me out to get ready for the next recording and the next streaming. Dustin will run off to another room where he will give his next talk about writing analyzers. So if you're interested in going to that and you don't know where it is, you can follow Dustin as he runs out the door. When I'm done answering questions here, I'll also go to the booth and hang out there, and so come and answer all those questions that we didn't have time for in this packed session. All right? And before I take we take the questions, again, I want to remind you, if you didn't already, if you were grumpy and Dustin convinced you to wait, please evaluate the session now.
I hope you're happy now.
And we really hope you're happy. All right? So we have a question here in the middle.
Yeah, quick question about .NET Core versus .NET Framework and the language, how the language relates to that. So, for example, could we see features in the language spec for C# that only apply to Core in future?
Could we see features that only apply to Core in the future? I think, in principle, yes. I think if Core takes over 90-some%, then a sufficiently big section of the world, or of the addressable space for a new version of C# or Visual Basic, then we would certainly consider it, yes. There are things we can do with also with the Core CLR that we might not be able to do on the desktop in the future. So it would be a consideration. It's not in the plan right now to differentiate the two. It's better if we can keep it all on one dialect, but it's certainly possible. Another question in the middle here?
Yeah, my question is, you had a syntax where you don't have to have a temporary and a return. You can make things very concise now with the refactorings. Mm-hmm. Is there a way to set a breakpoint so that you can still see the value before it gets returned?
Yes, I believe you can set a breakpoint on the expression itself. But to actually see the value before it gets returned,
yeah. So after the expression has been evaluated?
No, I don't. Not within the expression body, no. Unfortunately not.
That would be nice.
That would be very nice.
Breakpoint on
absolutely.
Semicolon. Yeah.
Yeah, breakpoint and semicolon. Yeah.
Exactly. Yeah, we should think about that.
Yeah,
that's a great suggestion. Any more questions? We have one over there. Yes.
In your tuple list of features, are you planning on supporting named tuples?
Named tuples, yes, and that is what well, depends on what you mean by named. These tuples were
Python style.
The tuples themselves do not have a name. The tuple type does not have a name. the members do have names in the proposal we have now. Is that what you mean?
Yes.
Yes. We think that when you get a tuple back from a method, say, it's really kind of confusing if you get 3 ints or 3 strings. Like, which is which? How do I decide what to do with them? Then I have to go and read documentation. It's better if it's self-documenting. And so we want some form of names in there. Now, what's not clear is, should tuples be equivalent across different names for the same members if they have the same types or stuff like that? That's in the design details. But the current plan is definitely to go with names. So again, in parallel with parameter lists, you would sort of have return lists when they're in that position with names and types.
Thank you.
Yep. We can have one quick question. Let's take it here.
So I was just wondering if there's been any thoughts to like AOP and doing stuff like exception handling more natively with attributes.
So aspect-oriented programming is what you mean by AOP, right?
Yes.
A few people mean something else, but that's typically what it means. We haven't yet found the appetite or the motivating scenarios for adding it to the core of the language. Obviously, the more we A, open up the compiler logic through APIs, and B, put it open source, I think we're gradually introducing more opportunities for doing for other people or for outside of the language doing something based on attributes and rewrites or something like that. It's not been a core scenario we've designed for, but it's something that may drive future evolutions of the Roslyn API. And we're out of time. Thank you very much.